Hello, my name is Fernanda Garcia. Today I come to explain my poster called Synthesis and Characterization of Aluminum Oxide, Zinc Oxide, Janus-Type Micromotors. This project will be exhibited on the B9 new trends and nanoscience and nanotechnology, innovative synthesis, nanoproprietary theory, and challenge. For introduction, the Janus particles are named after Bill Gibbs, who in the Nobel Prize speech mentioned that, by their characteristic, nanoparticles are relative to Janus good, who have two faces, one looking to the future and other in the past. Janus-type particles can be created with different shapes, such as cylindrical, disc, spherical, snowman, and others. In Janus-Type Micromotor, each of in spherical plays a different role. A spherical can be modified depending on application, while the other hemisphere is responsible for the propulsion capacity, which is driven by chemical reaction and requires a field or specific compensation. In spherical phenomena, choose electrophoresis, diffusiophoresis, thermophoresis, and bubble propagation. High-speed micromotors as material of a great interest due to their wide application in different biomedical and environmental technologies. The masking metal has reported positive results for the synthesis of these materials. For its evaluation as a micromotor, we use a nanoparticle tracking analysis using an optical microscopy and imaging analysis, and regard the aluminum oxide zinc oxide Janus-Type particles with hydrogen peroxide under ultraviolet light. This technology is based on a laser beam passing through the sample chamber, and the particles suspended in the path of the beam skirting the line it shoots away to there can be easily seen to the microscope, which must be compared to the video camera and recorded movement. The hypothesis in this project is that Janus-Type particles of aluminum oxide, zinc oxide Janus-Type is synthesized by the masking technology present anatomous movement, which results in use of micromotors. Continued with the metals, all chemistry rangers were analytic gradual purification without any future purifications. For the synthesis of silicon oxide particles, we prepared a solution of ethanol, water, and ammonium hydroxide. Was an agitation for 15 minutes, then was added drop by drop tetraethyl or to silicate in agitation for 45 minutes. The result solution was centrifuged and washed with ethanol. Then the result solids was dried at 120 Celsius for 24 hours. For the synthesis of hydroxide oxide aluminum particles, we have prepared a solution of aluminum nitride and a solution of aluminum hydroxide of 1% volume. We are mixed for agitation for 15 minutes to enough homogenization. In a standard experiment to sodium hydroxide and 1% volume, oxide solution particles were aided in agitation for 15 minutes in an ultrasonic bath. Sequences, the solution was aimed by constant agitation and drop by drop for a solution of hydroxide sodium aluminum. The result solution was aged and agitation for 24 hours, then centrifuged and washed with ethanol. Finally, the samples were dried at 90 Celsius for 24 hours. To obtain Janus-Type particles of oxide aluminum, oxide zinc, the masking method was used. The hydroxide oxide aluminum particles were supposed in ethanol and deposition by spin coating at 200–400 rpm on PMMI substrate. Secondly, the substrate was heat-treated at 120 Celsius for 5 minutes in order to embed the particles. Once cooled, the substrate was introduced in a solution of zinc nitride for 14 hours without agitation, then immersion in sodium hydroxide and pH once for 20 minutes, and then rinsed with distillation water and dry in the air. To detach the particles, the PMM substrate was introduced in isopropanol and used bath for 5 minutes. The supernatant was centrifuged and washed with isopropanol and acetone. Finally, the recombinant dose was calcined at 300 Celsius for 4 hours to obtain the Janus-Type particles of oxide aluminum, oxide zinc. For micromotor evaluation of aluminum acid zinc oxide particles, 5% volume of hydrogen peroxide was poured onto a clean glass cylinder. The dispersion of particles in distillation water was aimed. Later, it will be irradiated with light UV lamp. The movement of the micromotor was recognized by optical microscopy, taking a video with UV lamp on and off. The project was measured using a FTIR between 0 and 4,500 cm last ones. In the figure 1, inside A, shows the spectral corresponding to the precipitation over silicon dioxide particles. The extreme blue runs to 3,700 to 2,1800 is a signal to a stressing vibration of oxide-hydroxide group in the hydroxide structure as well in a physical absorbed water. The shoulder on 1,638 cm last one is taken for the variant mode of absorption water. The bath located in 1,300 to 1,314 is corresponding to the nitrogen oxide group strength bands, while the band at 1,100 to 1,200 is development to the has aluminum oxide hydroxide mode. The other band located in 700 and 250 to 600 to 30 developed to the aluminum oxide vibration mode. In the figure 1b, we observe the diffraction partners corresponding to the power obtained by precipitation over silicon dioxide particles. We can observe the diffraction part by only characteristic plane of gamma boehmite. By using the silicon particles and the nucleus, we have a great control in the pairs. Addition to the boehmite range is directly transformed to aluminum oxide. The figure 2 corresponded to scanning the electron microscopic images of the oxide solution particles. We observed a morphology spherical. The image B corresponded to the hydroxide oxide aluminum particles. We observed a particles with spherical morphology with coating, which provided the growth of boehmite in the silicon oxide particles. The figure 2 corresponding to scene imaging and the imaging of Janus-Type particles. We observed a successful coating of the material and the contrast difference of one part of the particles with another is observed. 14% when irradiation with UV light. This metal the Janus particles have anatomic movements can be used like micromotors. The silicium oxide particles was obtained using a Stover method using an advanced size of 400 nanometer, as confirmed by SEM images. Sequently, these particles were recreated with aluminum nitride in the presence of sodium oxides, forming a homogeneous quantity of hydroxide oxide aluminum in the gamma-boehmite crystal phase. The masking method was employed to obtain a Janus-Type particle of oxide aluminum oxide zinc, and the asymmetrical morphology was confirmed through TEN and SEM images. Finally, the velocity of the Janus particles in the presence of peroxide hydroxide was estimated before and after UV line irradiation using a nanoparticle tracking analysis and imaging analysis. The result incremented a 14% in the advanced speed of the particles over duration, thereby confirming their behavior as micromotors. These are some references that we use in the project. And thank you for your attention.